And according to our curriculum, the next topic would be geometry. Very often kids don't like geometry, have difficulties with this, and any test, we have geometry. Statewide, we have geometry. And we have special course of geometry in high school. And usually students have difficulties with proof, when you have to prove. And my point, geometry is the most beautiful part of all this stuff. It's not difficult, very helpful, and easy. If you go in my observation, if you go through Not Big chapter 13, and you know the in-depth, it helps you a lot when you study in STI, Brooklyn Tech. Moreover, I remember some students who become leaders in the group because of this package. In this package, again, I'm not going to give this entire package, but it's not reasonable. We're going to go through topics. For each topic, for instance, area, today we study areas. You get supplementary materials, and just enjoy this. Think that geometry is not only interesting, nothing develop your brain imagination like geometry. And I love geometry. I have books for geometry. I probably show this book. Let me show a couple books of this. Written many years ago. This is one of classic book. One of classic book in geometry. You know, we study with Euclidean geometry. Okay. And this Euclidean geometry, or in this one, it was created 3,000 years ago. Euclidean book, not in the best condition, but this one, geometry. I believe you can see this year. Year is over there. 1,800, I don't know, see this or not?
Mm-hmm.
Yes, see this, 1,826.
Mm-hmm.
And this Euclidean geometry.
Yep.
It's version of his book, published a while ago. And guess what? He was genius, definitely, when he created all this stuff. Even nowadays, you study geometry, the same geometry, but exercise much easier. Or another his book. This was beautiful book. Elemental Principle Geometry, Euclidean. Okay, you see this? It was published, I don't know if you see this or not. 1,600, where is it?
84.
1,684. These books. And this extremely interesting geometry, develop a lot of stuff. I have some books for 15th century in different office. You see how he make these drawings, all this stuff? Can you believe it? 1,000 years ago, thousands. Euclidean. Even I have a book how he solved this geometry. This pretend like use this is book, solving workbook for these books for many problems, etc., etc. I'm gonna see how this genius look like. Euclidean. I make some rearrangement here. Here it is. This is a person who created this geometry. Euclidean. Great genius. Okay. In university, you study not only geometry Euclidean, but also we have different geometries. For instance, in geometry, in Euclidean geometry, total of inner angles of any triangle, if you take any triangle, 180 degrees. You studied this in school, right? if you take any triangle, let me put scale in triangle, and this angle A, B, and C. Angle A plus angle B plus angle C, all is 180 degrees. So in our course we use this one. We set of axiom, etc., but this is Euclidean geometry. For comparison, we have also Riemann geometry. In Riemann geometry, pretend this is sphere. And I put a ruler on sphere and try to make a triangle. The triangle would look like this. And total of these inner angles in Riemann geometry, if you do the same, the total would be greater than 180 degrees. For instance, we have another geometry, Lobachevsky geometry. It's space. You know, space is banded, right? If I make this kind of triangle in this space, this Lobachevsky geometry, and total of inner angles of this in this Lobachevsky geometry, it would be less than 180 degrees. But this you study in nice colleges, you decided to be in this topic. For our course, we doing this stuff. Okay, so total of inner angles of any triangle equals to 180 degrees. I remember I asked one kid, what is total in angles of any triangle? Said he was very proud. You know what he answered? Three total inner angles, because we have 3 angles. But we're talking about measurement in degrees or radians. So far, so good. So geometry is not only to pass, let me put aside this beautiful box. It's not only to pass the test. Geometry mainly to develop your analytical thinking skill. And plus, it helps you a lot to solve many problems, real problems. I give you a few examples of this. Few examples from real life. Pretend you want to buy a pizza. Example number 1. And there are 2 options. Let me put this way. There are 2 options, 2 pizzas. And let's say diameter of this pizza the same. 44, big pizza. 44. Or let me put this way. I choose nice numbers. Let's say this is 22, this 22, and this is one pizza which 44. And price of this is $10. $10. And $20. What option you will choose? A, these 2 guys, or B? Let's what? Who would choose A? Put your hands down. Who would choose B? Who is not confident? Okay, look at this. If you pretend it's the same quality, in 5th grade you studied the area of circle equals pi r squared. Or you have another formula of pi d squared over 4. And let's find ratio of this area large to area small. Area large would be pi times 44 to the second over 4. Area small, pi times 22 to the second over 4, and multiply by 2 because we have two pizzas. So far so good? Now, when you divide, you use keep change flip rule, right? So pi times 44 to the second over 4. Instead of division, use multiplication. Keep change flip. And put 4 over 2 pi 22nd to second power. I write here 2 to second power. Now pi cancel out, 4 cancel out, right? And we have 44 over 22 to the second, and divide by 2. 22 goes into 44 two times. 2 to the second is 4. 4 divided by 2, this is 2. So in this case, this pizza is equivalent or 2 by 2 for the same like 4 pizzas. So this equivalent of 2 pairs is 1 pair and another pair. So this is more efficient. Okay, it's the same like for this big pizza, you buy actually 4 small pizzas. Every time, it's not only pizza. Let's go to 3-dimensional problem. Any questions so far, students? Everybody, moms go shopping and you help to do shopping. Give another example. Pretend you decided to buy, I don't know what, some fruits, grapefruits. Different quality. You see sale. Problem number 2. And you have 3 grapefruits. And the radius of the grapefruits is 1 unit. I don't care which one, is unit of inch, pretend 1. And each of these is $1. Versus this big one, and this radius is 3 inches. And this is 3-dimensional. 3-dimensional, it's not pizza. This is 3-dimensional, 3D problem, 3D. I have seen many times people like this. This is 3, this is 1. Now we have some ideas. What is better? What do you think? Who think to buy 3 is better? Let's see. Who think to buy 1 at the same? And this is $3, by the way. But again, who think to buy this 3 is better than 1? Okay, put your hands down. And who think the buying 1 is better than 3? Definitely, it's similar what we did right now with you. But can you see how many times is better? Write down, what do you think? How much time is better? Any ideas? Type it, type. Scientific guess. Scientific guess. Yes, Matthew. Okay, good. Daniel, I got your answer. Anybody else? How much time is better? Okay, good. Anybody else? Let me solve this problem. So this three-dimensional and volume for sphere, I use different color. We will cover this, don't worry. Volume for sphere equals 4/3 pi r cubed. So if you have a sphere, volume based on this formula. Let me do this. So ratio of volume large to volume small equals 4/3 pi times 3 to the third power. Divide by 4/3 pi times 1 to the third power. And multiply by 3 because we have what? We have 3 fruits. Now 4/3 cancel out, pi cancel out. And what we have here? We have 3 to the third divided by 3 and 1. 1 has no impact result. And you remember how we operate with powers. It's the same as 3 to power 3 minus 1, which is 3 to power 2. 9 times. When you buy this one, it's the same like 9 times 3. It's the same based on amount of this stuff. It's the same like 9 times 3, 9 times bigger than this volume. It's the same like 27 this small. Guys, can you believe it? When you buy it, you never think about this. I would never buy this one. Never. Is it impressive? Instead of this, you're buying 27. Even people who selling this, they have no idea how much money they're losing in this case. There's a basic of geometry. Okay, a couple more examples. Couple more. Do you have any questions? No questions. For instance, everybody during hot summer days buying what? What are you buying during summer days, hot summer days? Ice cream, right? And ice cream look like this. Example number 3. It's a cone. Let me put it a little bit low here. This is a cone. Okay, with this stuff. And this is you eating this cone. There's your eye. And usually you look from the top to bottom, right? And person who decided to make this cone, he become millionaire. Why? Because before this cone, it was different kind of ice cream. It was this kind of ice cream in many countries, Plombier, for instance. And pretend this diameter is the same. The same. Pretend diameter is 2 inches or 3 inches, 3 units. But volume of cylinder equals area of base times height. Volume of cone, and this is height. And imagine height is the same. I deliberately put the same level, the same height. And volume of cone equals 1/3 area of base times height. To make impression this is big, they put some part of sphere on the top. You're looking from the top, oh, so nice. You see this one. But actually here there is no ice cream at all. And what happens? They charge the same way by they stealing from you 2/3 of volume of this ice cream. Because if I make this one, you're buying this one, right? And they stealing from you. So person who invented this cone idea, you're losing your money. 2/3 goes to him. And you're buying only 1/3 for charge of entire ice cream. I can get many examples where everywhere around us geometry. So think about, I use geometry in my scientific research a lot. For instance, many years ago we studied, I give example of real project, one of my projects. On this project we study, lymphocytes in blood. Who knows this word? Lymphocytes. Okay, you study biology. Yes, you know lymphocytes. Okay, this is very important. I will not go in depth in biology. It's different story. It's not class of biology because my major is mathematical modeling in biology and medical fields, right? We're doing a lot of stuff, we do a lot of research. And what we did, imagine we have lymphocytes. We studied the lymphocytes under microscope. And we have this body of lymphocyte, example number 4. Example number 4. So then we study lymphocytes. And it has nucleus. Okay. And imagine we have robotic micro. How we study lymphocytes? Usually we have blood smear, right? It's a piece of glass. After that, medical professional take drop of glass, drop of blood, and make thin film on this piece of glass and stain using special chemicals to make some color. And after that, we use this blood smear, we put under microscope. And in drop of blood, we have tons of different particles, let me put this way, right? Erythrocytes, lymphocytes, etc. After that, we put under our robotic microscope. It's scanning and moving by microns like this. And special AI recognize these lymphocytes because we have not only lymphocytes, we have different objects. And after that, robotic microscope automatically measure all these parameters. We count based on this ratio of area of these lymphocytes to nucleus. We study different parameters. For instance, we measure this D1, we measure this D1, etc. And we study special regression lines. And based only by drop of blood, we can tell if person has cancer or not. If he or she does not have cancer, how close he to cancer is. Risk. In addition, we can even tell about tumor localization. Can you believe? Just look, imagine we took drop of blood, and we can predict localization of tumor only by blood smear. You want to see how it look like? I can show on the screen in a moment. Would you like to see how it look like? Very fast. Okay, just a sec. Couple minutes. A real project based on geometry. Just a sec. Yes. Let me open one. We have tons of this presentation very fast. So this is real project. I name it blood self-morphometric method with my colleagues. And we created a company in Germany where we studied these lymphocytes. Where is it here? It's opening. Okay, good. Okay. Okay, it's one of our company, American Medical Technologies, and this logo relate to this stuff. I show just few slides from here. You can see my screen? Okay. So early cancer detection. So I will skip this. So this my colleagues we work with. Okay, this robotic microscope, this different diagrams how we work with. Okay, this our patent. We file a patent. This is your name and my colleagues. And this we study lymphocytes using this robotic microscope and this computer system. Okay, so some discrepancy here we have on this computer. Let me switch some of them. Okay. For instance, this is how it looks like. You see, this is lymphocytes, this is nuclear, and system measure all this stuff. This our robotic microscope. We have set of very serious system with AI, and all this measurement goes to the screen. And based on this, what I show you on the screen right now, nuclear cell nuclear ratio, and after that we build regression lines. By these regression lines, we can tell a lot. We can tell if the person has cancer or not, how close he is to cancer or she. Okay, even it's like, you know, dactyloscopy based on this shape, for instance, based on shape of regression line, we can tell localization of tumor only by drop of this. So there's a big research we did. Behind the scene, what? This was cancer risk localization, and this was one of this idea for physician to make diagnosis from different perspective. This is about it. So this is long presentation, but I not go to all this technology, how we did, how we measure this, every microns here. You see on the screen, right? I believe. Behind the scene geometry. People study blood for hundred years, but medical doctors, they don't study geometry too much. And we have a lot of advantages in this case. This is blood self-morphometric method. And I have many research. We don't have time, unfortunately, to go through this, which done in my corporations, which based on geometry. Geometry is beautiful. Now, let's go to our topic, to geometry. Now, at the beginning, I want to show you that geometry is not solving SHSAT equation. Geometry around us. Every time you think about this one, it's true. Now, would you like to have a break? Somebody writing question if to go to bathroom. Who would like to go to bathroom 2 minutes? Go to bathroom for 2 minutes and we start solving geometrical problems right now together with you. We have a lot of fun.